I have shown here a shorter method that can be also described as method avoiding complication. If we have to find the derivative of such form sin of x square, we get the result this one. Also we can apply the method already I have discussed in the earlier problem. You can take x square equal to new variable, say u. Shorter method already I have taken tan x equal to u. Therefore let tan of x plus h. Here tan of x plus h is there. Therefore I take tan of x plus h is equal to u plus k. That means tan x plus k. Therefore k equal to tan of x plus h minus tan x. Now if h is taken to be 0, then what will happen? Tan x minus tan x, that means 0. Therefore I can write k tends to 0 as h tends to 0. Then this one dy dx or f dash x can be written as, therefore f dash x is equal to limit h tends to 0, also k tends to 0. I can write here root over u plus k minus root u by h. These are long one. We have taken this, therefore the reduced form is this one. Now this can be written as, here k, h both present, therefore I write here h tends to 0, k tends to 0. That can be written as limit k tends to 0 root over u plus k minus root u by k into k by h. For finding the limit or limiting value of this, to get the standard limit form, I have replaced h by k, and that is multiplied by k by h. Now this is of the form limit x tends to a fx into gx. Therefore that is equal to limit k tends to 0 root over u plus k minus root u by k into limit h tends to 0. Now k is equal to this one, therefore this will be already we have calculated k, this one, this k is replaced by this one. Now we calculate. For that I rub this part. Now I find irrational part at the numerator of this limit, and we rationalize. limit k tends to 0. After rationalization, it will be u plus k minus u k into under square root u plus k plus u, and for this we have to proceed as discussed earlier. That means expressing tan theta as sin theta by cos theta. Now this one, limit k tends to 0, k by k into under square root symbol u plus k plus root u into limit h tends to 0. We simplify. Numerator will be sin of x plus h into cos x minus cos of x plus h into sin x. Denominator will be h cos of x plus h into cos x. Now this k cancelled. Finally we put k equal to 0. We get 2 root over u into limit h tends to 0. Sin a cos b minus cos a sin b form. That means sin of x plus h minus x by h cos of x plus h. Since cos x is independent of h, therefore this can be taken outside into 1 by cos x. 1 by 2, already we have taken u equal to tan x. That means this becomes 2 root over tan x into 1 by cos x is sec x into limit h tends to 0. This is sin h, therefore we are getting the standard limit sin h by h into, there is 1 cos of x plus h. Applying the theorem of limits, we can write limit h tends to 0 cos of x plus h. Therefore finally we get value of this one is 1, therefore, and this one is 1 by cos x, therefore this is, from here we get sec x. Sec x into sec x means sec square x by 2 root over tan x into 1. Therefore finally ddx of root over tan x is equal to sec square x by 2 root over tan x. I have shown here a shorter method that can be also described as the method avoiding complication. By taking tan x equal to a, then tan of x plus h, that is u plus k. From that we get k equal to this one, and what we find, as h tends to 0, k tends to 0, then from the original form using definition we got f dash is equal to limit h tends to 0, numerator root over tan of x plus h minus root tan x divided by h, and after this assumption the reduced form will be this one, and I have proceeded like this. This is actually a quite simpler one, but already I have mentioned that limit also can be found using the method discussed earlier. Now I move to find the derivative of this one. Number 2, let fx equal to sine of x square, that is also y. Therefore, f of x plus h is equal to sine of x plus h whole square. Therefore, f of x plus h minus fx, that is equal to sine of x plus h whole square minus sine x square. Now we can apply the transformation formula sin c minus sin d. This will be 2 cos x plus h whole square plus x square divided by 2 into sin x plus h whole square minus x square divided by 2. Sin c minus sin d is 2 cos of c plus d by 2 into sin of c minus d by 2. Therefore, from definition, f dash x is equal to limit h tends to 0, f of x plus h minus fx divided by h. We put the value limit h tends to 0, to cos of, if we simplify, it will be 2x square plus 2xh plus h square whole divided by 2 into sin x plus h whole square minus x square will be cancelled. Finally, we will get 2hx plus a square divided by 2. Denominator will be h. Now I move here. F dash x equal to limit h tends to 0 cos of, if we divide, what we get, x square plus xh plus a square by 2. This one into limit h tends to 0 sine, if we divide by 2hx plus h square by 2, what do we get? H into x plus h by 2 divided by, sorry, not divided by, already I have divided, all divided by h. Now I can take these two at the denominator, though it is not needed here. Okay. Now finally we put h equal to 0 here. What we get? This one becomes cos of x square. Now to get the standard limit form, we write it as limit h tends to 0 sine of h x plus h by 2 by h into x plus h by 2, and this 2 is taken outside, into x plus h by 2. To get the standard limit form, since angle of this sine ratio is h into within brackets x plus h by 2, we have to take that form here, sine theta by theta, theta tends to 0. To get that form, I have written like this. This one is to be balanced, that is why multiplied by this. Now this is equal to 2 cos of x square into, take this as new variable, taking x plus h by 2 into h equal to say theta. Therefore theta tends to 0 as h tends to 0. To calculate this limit, I have taken this angle as new symbol, say theta, new angle. Therefore what we find, as h tends to 0, theta tends to 0. Therefore this becomes, limit theta tends to 0 sine theta by theta into, where we can apply the theorem, limit h tends to 0 x plus h by 2. A bit larger, therefore finally what we get, 2 cos x square, value of this limit is 1, and this one will be x, therefore 2x cos of x square. A bit larger, therefore I can write, therefore ddx sine of x square I can put second brackets, is equal to 2x cos of x square. If we have to find the derivative of such form sine of x square, we get the result this one. Also we can apply the method already I have discussed in the earlier problem. You can take x square equal to new variable, say u. Therefore x plus h whole square, that will be taken as u plus k, and you can proceed to find the derivative of sine of x square as discussed earlier. Therefore we have discussed here how to find the derivative of some, say, complicated function. We can call this a bit complicated one with the help of definition. Next, I am going to discuss the fundamental theorems of differentiation or fundamental laws of differentiation. Fundamental theorems or fundamental laws of differentiation. Write serially. I give italic ddx of c equal to 0, c constant. Number 2, ddx c into fx, that is equal to c into f dash x. Number 3, ddx u plus minus v is equal to du dx plus minus dv dx. Here u is function of x and v is also function of x. We call this one some difference law. Then we have ddx u dv dx plus v du dx. U, v are functions of x. Therefore, derivative of the product of the functions u, v is this one, u dv dx plus v du dx. We call it as product law. Number 5, ddx of u by v, that will be equal to v square v into du dx minus u into dv dx. Quotient law. These are the fundamental theorems of differentiation. First of all, derivative of constant, that will be equal to 0. Then derivative of the product of c and fx, where fx is function, c is constant, will be equal to c into f dash x. Then sum difference formula, ddx of u plus minus v is equal to du dx plus minus dv dx. That means in case of plus, it will be du dx plus dv dx, and in case of minus, it will be du dx minus dv dx. This is sum difference formula. Then product law, derivative of product of two functions u and v, that will be equal to u into derivative of dv dx plus v into du dx we can remember this like u into derivative of the second function, first function into derivative of the second function plus second function into derivative of the function, first function. We call this one as derivative of two functions. Then quotient law ddx of u by v, that will be equal to, first of all you remember like this, first you write the denominator. Denominator will be v square, numerator will be v into du dx minus u into dv dx. First if you write v square, then start v. These theorems can be proved easily. I show these two, proof of these first two. You can do yourself the proof of the remaining. Also you can check or you can see from your textbook. Proof. Let first of all number 1, fx equal to c, therefore f of x plus h will be c. Since constant, c is constant, therefore it is not depending on the variable or independent variable x, therefore f of x plus h will be equal to c. Therefore f of x plus h minus fx will be equal to c minus c, which is equal to 0. Therefore by definition d dx of c is equal to limit h tends to 0 f of x plus h minus fx divided by h, limit h tends to 0, 0 by h, that is equal to 0. Therefore d dx of c, that is constant, equal to 0. Now I prove the second one. It is quite easier, you can solve yourself. Now I prove the next one. Here we take cfx, therefore let c into fx equal to, I take the new one, this one. Therefore phi of x plus h phi of x plus h minus phi x will be taking c into fx equal to new variable say phi x. Therefore we have to calculate phi of x plus h, that will be this. Therefore phi of x plus h minus phi x will be equal to c f of x plus h minus c into fx. C is the common factor, therefore c within bracket f of x plus h minus fx. Therefore from definition phi dash x, I have taken phi x, is equal to limit h tends to 0 phi of x plus h minus phi x, numerator and denominator is h. Now I put this value, limit h tends to 0, c within brackets f of x plus h minus fx divided by h. Now c is constant as per the formula or theorem of limit x tends to a, c into fx is equal to c into limit x tends to a fx. Therefore c is taken outside, therefore c into limit h tends to 0 f of x plus h minus fx by h. Now this is the formula of f dash x. Therefore finally it will be phi dash x is equal to c into f dash x. Therefore we have deduced ddx of c fx equal to c into f dash x.